Paper 2, question 13c. There's our answers from parts A and B. We're just going to zoom in on this graph a little bit so we can see a little bit more closely what's happening here for part C. Now, the tangent through F, if we look at this tangent down here, it's not going to intersect the graph again, but the tangent at this inflection point is when x is equal to 1. So I'm just going to type in x equals 1 to show that tangent in place, and it seems to intersect over here at point Q. So this intersection point seems to be when f1 is equal to f2. So I can quickly go back to my calculator page and I can do f1 of x is equal to f2 of x, and when is this statement true? I'll do menu, algebra, numerical solve that expression for x, and it tells me that it's true when x is 0, which we knew because that's where the graphs originally met on the y-axis. We're now going to look for another solution. So I'll press Control equals, so given x is less than 0, and I get something that's very, very small, less than 0. Let's see if we can force the issue, make it go much further less than 0. It seems not to want to find it, but we can absolutely see that there is a value there. Let's see if we can go to intersection graph. So menu, analyze graph, intersections. I'll go to the left, I'll go to the right, and we seem to have the value negative 1.33. Now the question specifically wants the exact coordinates of Q, so what we'd have to do is make sure that negative 1.33 is the minus 4/3 that we expect it to be. So what we can do is, well, f1 of x is a polynomial, and f2 of x is another polynomial. So what we could do is menu, algebra, polynomial tools. Let's try that again. Menu, algebra, polynomial tools, and do real roots of the polynomial. And if we do f1 of x, subtract off f2 of x, and solve it for x, we do indeed get the minus 4/3. And we've got 3 solutions when x is 0. So there we go. We have our x coordinate for point Q. And to get the y coordinate, I can just press var f1 of minus 4/3, negative 4 divided by 3. And I get the value for 1, unsurprisingly, from the graph. Now we're being asked to find that equation of the normal. So let's just go back to this graph. I want the normal through this point. So I need to work out the derivative of the function when x is negative 4/3. So what I could do is let's just draw in the tangent. So menu, geometry, points and lines, tangent. I'll pick that graph and pick, well, I'm going to pick that point there, but it may not be the right point. Let's just press escape. Move all the screen clutter out the way, move those coordinates, that's from the intersection. This point here is moving up and down. Let's get its coordinates, so I'm going to press Control menu, coordinates and equations, and I want to edit its x coordinate, so it's negative 4 divided by 3, so it snaps to the right place. So this tangent is the one which I'm after, and I'm looking for a line that's perpendicular to it. So I'm going to do menu, geometry, construction, perpendicular line. It's going to be that point of intersection and that line there. And so this line that's turned up, that's the normal I'm wanting. I'll just press escape to get out of perpendicular mode. So I go over that line, press Control menu, coordinates and equations, and I seem to have this expression here. Now obviously it's a bit of a decimal approximation. If you were to carry everything through exactly as no doubt the question is intending for you to do, you should get values which compare to the decimals on show. Part C is done.